So good afternoon, everyone. So just to make sure we're all in the right session, you're all wanting to see advanced analytics in the cloud, right? Okay, very good. We're going to do some machine learning using Azure Machine Learning. I got a couple of slides, like only 5 or 6, and the rest is all demo. So together we are going to create a model. We are going to train a model, and we're going to do some predictions inside Azure Machine Learning, all live inside the demo. So just to be warned that if anything goes wrong, it's the demo, of course. So a little bit about myself. My name is Henrico van der Laar. I'm from the Netherlands. And I'm a data and advanced analytical consultant at Data Heroes. And Data Heroes is my own company. So I can give myself whatever title I prefer. And this one sounds pretty good, I think. I'm also a crazy data scientist. If you want to know what that is, I encourage you to go to www.crazydatascience.com and find out. Microsoft Data Platform MVP for the last 5 years. An author, I wrote a book about SQL Server weight statistics. I'm a speaker, obviously. And I also blog regularly on my blog, which is all in the slides that they're going to share with you today. Little bit background on myself. Originally, I am a DBA. Are there any other DBAs in the room? Database administrators? Oh dear. Are there any developers in the room? Okay. So, us DBAs, we always like to make jokes about developers and their query writing skills, but I will avoid those during this session, I think. But I started in the world of advanced analytics or data science like 5 years ago. So I kind of taught myself everything I know, starting with math and statistics, learned R, learned Python, did all that stuff for the last 5 years. As it turns out to be, the situation is that those 5 years ago when I started was actually the perfect moment to start in the world of data science, because right now a lot of organizations want to do something with data science or advanced analytics or statistical methods to extract meaning from their data or create machine learning models for a lot of reasons. For competitive advantages, to have a better forecast of sales or create a better product using advanced analytics, to improve quality of their company or their product or their business or their services, optimizing production, something that happens a lot these days with things like predictive maintenance, which is the most famous example of an elevator manufacturer where the guy comes to fix the elevator before it's broken, and cost savings. Many of the organizations that end up wanting advanced analytics get to that area because they run into issues with their current BI platform. So they usually, well, all of those organizations have a business intelligence process in which they have a data warehouse, they generate dashboards, they get meaning from their data. But they run into problems with the dashboard because they can't do things like machine learning on top of it, or they want to expand it, they want to do more with their data. So there are a number of reasons why to roll into advanced analytics. But the main issue with that is, how do you start? How do you take the next step in analytics? How do you move from a company that does traditional data warehousing, traditional BI, and take a step to advanced analytics or data science? Are there people in the room who have made that step? Nobody? I'm going to help you. Now, seriously, it is a very difficult step to get from traditional BI to advanced analytics because you have to deal with data quality. Is all my data registered correctly? You have to define use cases for data science. You have to know people that understand the statistics, that know what machine learning models do, what they represent, what it means to use them. So it's very difficult to start with. And to make things even more complex, there are a lot of solutions available to get started with it. And these are just a number of solutions that do something with data science or advanced analytics. There's R, which is a statistical language, a kind of programming language, to create machine learning models or to do predictions or do statistical analysis of data. Python, another very popular language in the data science world, but also still some hardcore statistical tools like SPSS, MATLAB, SAS, Octave. I haven't even wrote down all other solutions like Spark, for instance, or these days Databricks, are all solutions that can help you get to adopt data science, to create machine learning models, to do predictions, to do analytical exploration of your data. So why not start with something that's easy? Because most of the products I've just shown you are rather complicated to get started with. If you are not familiar with Python and you want to do a data science product in Python, you'll have to learn Python first. If you're not familiar with SPSS, you have to learn how SPSS works first, which is, of course, all very good. But if you're in a situation where you want to explore, is data science something we can do in our organization, or is it something I can do? It can get very complicated very fast. But there is a solution that's easy to use and scales very easily, which is the title of this session, Azure Machine Learning. Because Azure Machine Learning is a service in the cloud, which is very easy to use, doesn't directly need any programming background, so you can get started with it right away, and kind of helps you and guides you in the process of creating machine learning models, or doing data predictions, or even doing very advanced things like object detection. A lot of use cases you can do with Azure Machine Learning. Drag and drop functionality, no programming. And the rest of the session, after 4 more slides, I'm going to show you exactly how it works. It's very intuitive to use. It's very easy to use, very simple. It's also very easy to explain to your colleagues. So if you're building something, say a machine learning model, and you want to explain it to your colleagues, it can get very difficult if your colleague isn't necessarily very good in statistics or in R or in Python. So what Azure Machine Learning does, it kind of explains your experiment, your project, in a more visual manner. You still got all those little knobs you can turn and all the little details you can explore in Azure Machine Learning, but it's a very friendly manner. It supports a lot of stuff. And I got a slide with all the things that it supports, which has been expanded even more recently. You can connect to your on-premises database, SQL Server database if you want to. You can import CSV files. You can connect to Hadoop clusters, HD Insight, Data Lake. You name it, you can connect to it, basically. So it's very powerful to get to your data. It has a very high uptime. And for me, and like I said, I'm a Dutch guy. I know many of you are. You can get started for absolutely free. So you don't have to pay anything to get started with Azure Machine Learning. There are some restrictions. You can't read from an on-premise SQL Server database, which can be a big restriction, but if you're just trying it out and seeing, okay, does our data work in a machine learning model, you can import it through CSV or another manner. You can only have a 1-hour experiment duration, which means when you, for instance, train a machine learning model, it can only run for a maximum of 1 hour. Which in most cases, again, is fine. And there are some other small limitations that you don't have if you have the standard edition, which you have to pay a little bit for, but you get a lot more from it. This is a very big poster that's absolutely unreadable on these screens, but it sums up all kinds of things you can do in Azure Machine Learning. What kind of machine learning algorithms are supported? What kind of data sources are supported? How do you train? How do you score models? All that kind of stuff. I left it in the slide, so if you want to look at this presentation at a later time or download the presentation, you can look at it yourself and figure out, okay, is this in there? Yes, it is. But I just want to go and get started and showing you what it looks like, how it works, and how we can build a machine learning model. right. So the first place, if you want to get started with Azure Machine Learning, is the Azure Machine Learning Studio. When you register for using Azure Machine Learning, you get access to the Azure Machine Learning Studio, which is, again, a web-based service you can use to do all your machine learning thingies. I'm going to sign in. And it will load all the experiments I already created. Don't look at the names or anything. The Belgian beer recommender is there for a very specific reason. I enjoy Belgian beers, and Azure Machine Learning helps me regularly by telling me what beer to drink next, which is very useful. The surviving Halloween one, we can look into that one later, but it will basically tell you whether or not you're going to die in a horror movie. But this is all crazy data science stuff, so you can look at that through the YouTube channel. What we are going to do is we're going to create a new blank experiment from scratch, and we're going to import some data. As you can see directly, is the canvas is a very visual experience. So the way this works is you kind of drag things that are here on the left, modules or functions, all kinds of things, you drag them onto the canvas, you configure them, and you connect them. Very easy to use, very easy to understand. The first thing we need to do if we want to do anything with machine learning is we need to have some data. So I can do two things. I can import a CSV file, or I can read it directly from an on-premise SQL database, which is the thing I'm going to do. So I'm going to use the import data module. Drag it, and I can configure it. So I'm launching a wizard. And these are actually a couple of the data sources you can use by using the import data wizard. There are multiple others available directly through modules. I'm going to go for the on-premise, and it needs to configure something. Now, the on-premise machine is actually this VM we're on now, which has a SQL Server database, and which has a table called automobile, which has all kinds of data about cars in it. Is there anyone who wants to sell his car between now and 2 weeks, perhaps? Looking to buy a new car? Okay, we're going to predict the price of a car using this data. So this is all information we stored. We're a car dealer. This is all the information we stored about our cars, and we want to predict the price when a new car comes in. So what would be the optimum price to sell this car for? So we captured all the little details about the cars, like what type is it, what is the fuel type. As you can see, it's all American data, but still it will work for us. We'll convert it somehow, but it has all the things about the cars. The way you can connect to your on-prem environment is through the integration runtime, which was previously called the Data Management Gateway. If you are working with Power BI and on-premise data or Azure Data Factory, you will probably be familiar with it. It's a little bit of software you install on a machine, and it kind of sets up a secure connection between your on-premise environment and Azure. So you can kind of directly connect from Azure to your on-premise network. I need to supply the server name, database name, and I need to configure some values to use as a login. So I'm using a SQL login, which is a username and password. If you want to, you can also use Active Directory authentication. But this is used to connect to my data source and get data from it. All right. And now it wants a query. So here you can do all kinds of things, like get your data out of the database. What I'm going to do is I'm going to get the entire table I've just shown you and completely load it into Azure. So I'm going to do a select star to completely load that data into Azure. Done. We've configured it. I'm going to check this little box so our presentation is a bit quicker. I can cache the results. So as soon as I run this, using the little button down here, Does this work? Yes. As soon as I click the run button at the bottom, it will start running this experiment in Azure. So the reason why I checked the use cache results is every time I run it, it would do a query to my on-premise database, get the data, and it takes a couple of seconds. And if you cache it, it's going to be way quicker. So let's run it and see what happens. It's done. And the beauty of Azure Machine Learning is data always goes from top to bottom. You can get information from every step it processed. So I can click on the results and data set, and I got some various options here to do something with this data. I can save it as a separate data set, which means it makes a copy of the data and stores it in blob storage on my storage account. I can visualize it, which is something we are going to do, or I can open a notebook. If you are familiar with notebooks, they are like, how would you describe notebooks? You write commands in a notebook and you can go through them step by step, cell by cell, and they are very frequently used to avoid having those huge scripts, but instead you kind of like cut it up into little pieces so it's easier to understand and process each step individually instead of having to run an entire script, which is very useful when you are doing data science stuff, especially in a team, because you can collaborate in notebooks. So you can say to your teammates, okay, I wrote this new notebook, can you check it? Can you check the code? And he can dynamically add stuff, remove stuff, change stuff. It's very friendly to work with. We're going to visualize it. And what you see here is the same data we saw on that SQL Server, but together with a couple of graphs. Everyone can see the graphs also in the back? Okay. Those are histograms. What it automatically does is for each column, automatically creates a histogram of the data distribution of that column. If you are doing data science or advanced analytics or statistical exploration, this is very helpful because usually one of the first steps you do is you look at the shape of your data. You want to know what is the average value, how does my data look like, what is my distribution, because that impacts your machine learning model. Because there is a relation between SQL and Azure, it also automatically understands what the column types are. So it automatically sees that this is a string feature for whatever reason. It sees that this is also a string feature, this is logical, and it sees that this is a numerical feature. So immediately, if you click on a numerical feature, you get all these statistics about that numerical feature. What is the average? What is the standard deviation? How many unique values? Very helpful. Again, very friendly. I can also type this in a single command in R, a summary and then a data frame, and you get the same results. But still, this is very helpful to immediately see this on the column you selected. So this is the easy stuff. We got data into Azure Machine Learning Studio. Now we're going to do something with it. And the first thing I'm going to do is I'm going to transform the data a bit with a module called Edit Metadata. And what Edit Metadata does is that you can say, okay, I got this column, and this column is a string value, but I want it to be a categorical value, for instance. Some machine learning algorithms prefer categorical values instead of normal string values. So you can do those kind of things. And the way you do that is you can connect to this other module. I can launch a column selector. It automatically sees all these columns because the data comes from top to bottom. So it directly sees, okay, we're dealing with these columns in this data set, and I can do things with it. I can say, okay, I want, with rules, I want that all the columns, or no, I want to start with no columns, and I want to include all the columns that have a column type of string. So think of this as like a filter. I'm filtering on what is the data you want to process by this module. I want to include all the string columns, and I want the data type to get to string, and I want to make it categorical. I can save it, or I can just run it. Gets deployed again, and it will immediately perform that step. And it will also cache the previous steps it's done. So if you've trained a model and you're doing stuff with the output, you don't need to retrain your model again. It's already done that. It saved a trained version of your model, so you can immediately work from there. Again, I can click on it. I can click on Visualize. And if everything worked the way it's supposed to do, it's now a categorical feature. So it changed my string features to a categorical feature. And a categorical feature is basically give me all the unique values and count how many occurrences there are inside of there. That's why you can see the histogram here as well. You can immediately see there are more than 30 Toyotas in this data set. All right. So this is all very simple. This is just grab a module, connect a module, configure it, press play, and things happen. And one of the drawbacks of this is that you're, of course, limited to what the module does in terms of functionality. Well, to counter that, you can also choose to run your own scripts. So if you want to, you can, for instance, get execute R script. You can load your data into the R script and run R code or Python code if you want to. Again, you connect it. So it usually says what the connection points do, various data inputs. So I'm connecting it to this. And I can click again on the module and copy paste a script here. What I'm going to do is I'm going to copy this one. You can select whichever version of R you prefer, the regular CRAN version or the Microsoft OpenR or R Open. I'm going to leave it at Microsoft R Open. And what's also very interesting for the people in the room that work a lot with R is that you can basically use every library that is available on CRAN or in the Microsoft R Open repository. You can load directly into Azure Machine Learning. So if you really like ggplot2, like I do, you can directly load it and do graphical stuff with your data. I'm not going to explain what the script does, but what it basically will do is it will create a matrix to show the correlation between the features or the columns. I can run this. And the first two steps were done instantly because it's already processed the data, so it doesn't have to do that again. And we get an execute R script, which gives us two outputs, a data set, and it gives us an R device output. On the data set, we can click visualize again and we get all our data back. But if you do all kinds of data manipulation in your R or Python script, you get the changed data frame or the changed table back from the R script. What's more interesting is we're going to look at the output of the R device. And we can see, even though the graphic is a bit small, this is the thing I've created in ggplot, our correlation matrix. So I can see which features have a strong correlation with other features, or correlation heat map as it's also called. It's a bit difficult to read, but you can see, for instance, that the weight of the car has a high correlation with price. And since we're doing some machine learning things, we start off with data exploration. So we want to find out what parts of the car or what features of the car have the largest impact on the price, because we are predicting the price. So in this case, we can immediately see, okay, the weight of the car has an impact on the price, a positive or a negative impact. We're not doing stats one-on-one here or something, but we want to look for those strongly correlated features if you want to have a good machine learning model. Just to show you what's capable with Azure Machine Learning. So if you have this complete R script that one of your data scientists wrote, which is not, you can't create it in the modules in Azure Machine Learning, you can also choose to just import the entire script and run the entire script straight in Azure Machine Learning. All right. I'm going to remove it because we don't necessarily need it. And we're going to train a model. And the way you normally do that, for those among us who are not very familiar with data science processes, is that we're going to split up our data. Because we want some data to train an algorithm on, and we kind of keep a little bit of the data away from the algorithm so it doesn't see it. So when we're done training, we can give the algorithm the data it has never seen and ask to do a prediction, and that's the way we can score how good our model is performing, basically. So to split data, you can very easily type in split, drag the split data module, connect, configure. We're going to do normal split rows, 0.9 split, which means on one side we get 90% of the rows, the other 10% goes out the other side. We can give in a randomized seed. You get some more additional options if you want to. This will be the 90% of the data, this exit. So this is what we're going to give to a model. But before we give it to a model, we have to drag in a module called train model, because that's exactly what we're going to do. And train model expects a data set, and it expects an untrained model, or better yet, an algorithm. So I'm connecting this one here, and now we need to select an algorithm. And there are a lot of algorithms. Hopefully I can open them here. Let's see. Let's do this. We're dealing with, we're going to predict a price. And a price is a numerical value. So what we're actually dealing with, there are a number of problems you're dealing with in data science. But generally, there are three different categories: classification, regression, and clustering. If you're dealing with a numerical value that you're trying to predict, you usually end up with regression. So we're looking for a regression algorithm. And these are a number of regression algorithms that are available in Azure Machine Learning. Going from decision tree regression to neural networks. We're going to start off relatively easy. And use boosted decision tree regression, which you can simply drag on the canvas and connect it to the train model. Here you can set all kinds of options for your algorithm. And it isn't as extensive as if, for instance, you're doing decision tree regression in R. In some cases, you have a couple of more options. In some cases, you have a couple of less options. Most of the algorithms in Azure Machine Learning have been defined by Microsoft very well and documented as well. So you can see on which general algorithm it was based. In this case, you can set all kinds of algorithm-specific configuration values here. I'm going to leave them all alone. But what I need to select in the train model is our label column. And a label column basically means what column do you want to predict. Like I said in the intro, we're going to predict the price of a car. So I'm going to select the price column. You can also select multiple columns if you want to. All right. This is going to train our model based on the boosted decision tree regression algorithm, and it's going to try to figure out what would be good parameters to predict the price of a car based on all these features of a car. To see how good we've done, we need to score it. So I'm going to drag in a score model, connect it again, and this is the thing that brings the training data and the testing data together. So I'm going to give all the data where my algorithm has been training on. The result is my algorithm. I'm going to send it to the score model, and then I'm going to introduce the data it has never seen before. This is the 10% of that data set. I'm going to send it here. What it's going to do is it's going to take that 10% of the data, going to give it to the model and ask the model make a prediction. And the good thing is we already know the price of that test data set. We know the price of that car. But because the model has never seen this data, it will do a prediction and it doesn't know the price of the car. So we can see what's the predicted price and what's the actual price and see, okay, how close are we? Did we do a good job using this algorithm? And to make that even more easier to see, we can drag in a module called evaluate. We're going to connect it. That shows it in a bit easier way to make it easier to understand. Yep, so I'm going to run this. Zoom out a bit. You can see on what step it's working on. So it's currently splitting our data. It's a lot of data, 160 rows, takes a lot of processing power. Come on. This is what you get with live demos. Something always goes wrong. This is taken way longer than it should. Let's see. I'm going to stop it. And I think I made a wrong choice with the algorithm. And I'm going to go to do normal linear regression because that's what I was supposed to do according to this little paper here that I wrote personally. That's what you get for improvising. Bad things happen. All right. Come on. And no, it doesn't want to connect. Forget this. I'm going to reload it again. Is it okay if I blame my Mac? It's the Mac. That's why it isn't working. It's not a cloud-based service issue. It's just the Mac. Here we go. All right. Let's try this again. And it's done with splitting data. So it's training my model now, and linear regression is actually the most simple algorithm used in machine learning, and it also turns out to be the most used algorithm in machine learning and in data science because it's simple, easy to explain, and you can do it on a whiteboard. And those are usually the best algorithms. So even though those neural networks are very cool and it sounds very awesome, you know, I built a convolutional neural network today. It's really cool stuff, but nobody really understands it. Only a handful of people. While linear regression, everyone understands it. So if you have to explain what's happening in the algorithm, you can very easily do it. So let's first look at the score model. And let's see how we predict it. So again, this is the data set that went in. This is the testing data. So these are 16 rows. This is 10% of my data. The algorithm has never seen before. So what it does during scoring, it adds labels. So the price is the actual price of the car, and the scored labels are what the algorithm predicted. And as you can see in the first one, it was relatively close. The second one was a bit meh, and the fourth one was like almost predicted to be twice as expensive. So if I'm a cars dealer, this algorithm isn't really performing very well for me if I want to buy those cars. I don't want to buy them too expensive. I want to buy them cheaply. To figure out what our general performance of our model is, we could compare all of those columns, but we can also get that from the evaluate model because it gets the general scoring of our algorithm and shows them in statistical value that are meaningful to your data scientists or to your analysts. They like to see things like coefficient of determination or mean absolute errors or root mean squared errors. So basically, very simple, mean absolute error, how far off in dollars, in this case, were we on average in our prediction. So on average, we were around $7,500 off, which is quite a huge margin considering the average price of the car. So that's not very good. So next step, we need to optimize this. We need to make a better prediction. Thankfully, nobody asked about the coefficient of determination being negative. Is there any statistician, data scientist in the room? Nobody dares to raise their hand? Okay. It shouldn't be negative. I don't know why it's reported back as negative by Azure Machine Learning, but it's not good. So what we can do is we can train in the same data flow, we can train another model. So we can again select the train model module, train model, connect our data set, so the same data. I can select another algorithm, we're still doing regression. So I'm going to do the boosted decision tree regression this time. I'm going to connect it to here. I'm going to tell it, I want you to predict the price column. We're going to add a score model because we want to see how good it did. Connect it and connect our test data again. So the data the algorithm has never seen. So as you can see, we're doing two things in parallel here. We're training two different algorithms on the same data, and we can bring those together in the evaluate model. So we can compare them directly and how they performed. So I'm going to run this. So it's training now. The other side is already done. Begun, I guess, because what I said, it's cached, so it's done really quick. Thankfully, the boosted decision tree decided to cooperate this time, so we should be able to see something soon. So let's look at the score model first. What did we predict? Again, the same 16 rows. Actual price versus scored labels. And you see, again, it's not perfect on that number because regression never is. If you ever see a prediction or a lot of predictions on the same data set that are exactly that number, something is wrong. There's always some error. There's always some wriggling room. In this case, it sees, however, that a lot of those predictions weren't that extremely high anymore. So it's a bit more closer to each other than the linear regression. Let's take a look at the evaluate model. And we get our metrics next to each other. And as you can see, the mean absolute error went down a lot. So instead of being more than $5,000 off in our prediction, we're on average around $1,300 off, which is way better. Still not perfect. We could be optimizing this even more, right? But still, it's better than linear regression. So this is this example is a very simple way of showing you how you can very easily test different algorithms on your data. Having to do this in R means you have to write a lot of scripts, you have to write a lot of comparison functions. It takes a lot more work than just dragging a couple of modules and connecting them. So it makes it easier. What I've shown you now is, technically speaking, not the correct way to do it. Normally you would partition your data and train your algorithms on the partition data or use folds for those in data science world. where you train your algorithms on a different set of data, but then on the same set again multiple times. But this is very easy to compare two algorithms together. Azure Machine Learning also supports other techniques to compare model performance, but are not in the presentation. So we can do two things now. We can now be happy, okay, $1,300 is fine, or we can try and make it even better. And one way to do that is to drag a module on top of it called Tune Model Hyperparameters. And what Tune Model Hyperparameters does, all these parameters here, like the maximum number of trees we're going to build, the maximum number of leaves, again, this is all in the algorithm itself. When you're doing machine learning, you're figuring out what is the right value. So you'll start with, okay, let's start with 10 trees. Okay, my performance is this. Let's do 20 trees. My performance is this. So you try all different settings. Manually, that's a very labor-intensive process. And what Tune Model Hyperparameters does, it will basically do that for you. So it will run the algorithm as many times as you like with all different variations of parameters. So I'm going to drag this one here, remove this one. And again, it expects a number of inputs like the untrained model, a training data set, and optionally a validation data set. You don't need to connect those. What I can do is I need to say, okay, what column are we predicting again? Where do I need to tune on? And what do you want me to tune on? So for dealing with classification, we got a couple of different metrics where you want to tune on. We're doing regression. And let's say we want to tune on, what did I write down? Coefficient of determination. A coefficient of determination for the statistical people is the R² value, which is basically how much of the data is my model explaining. Little side note. I want this value to be as good as possible. And a good R² value is as high as possible. But then I can do two things. I get the sweep results, like, okay, what parameters did I do? Because it's going to pick them randomly. And I got the trained best model. So it will also return to me the best model based on that R², the coefficient of determination, that it generated. And I can immediately use that in my process. I need to configure this one to be multiple parameters. Here I can say, okay, what kind of variations do you want to tune model hyperparameters to try out? I'm going to leave this default. You can try this yourself. And I'm going to run it. And this time it's going to take a little bit longer because the tune model hyperparameters is actually running the algorithm a number of times. I believe 5 times by default. So it picks random parameters and 5 times and then trains them based on that, on those parameters. All right, it's done. Now it's scoring and evaluating. So let's see what it's done. You can look at the sweep results, and we can see what different type of parameters it tried. So these are all settings based on boosted decision tree regression. If you have another algorithm, you will see different parameters here. The mean absolute error, these are all the statistics that show us how well our model performed. And the best one it generated was the top one with a 0.81 because we want to optimize for the coefficient of determination. You can add as many tries as you want in here. It all goes from your experimentation time. If you want to have try out 100 different parameters, it will do 100. It will just take longer, but you get some better results. Finally, it pushed the best model, the top model, to our score model. And if we look at evaluate model, we should be able to get a bit better results in the coefficient of determination. Now you notice, but the value during the tune model hyperparameters was something 81 something, but that was on the training data set. So this is the test data set, and it's actually performing a bit better here. So this is one way how you can train multiple models and get the best one out if you want to. For those that are interested, basically every step has some data coming out of there. So if you're interested in seeing some of the values that were used during the linear regression, you can see them here. The same for the decision trees, you can see them here as well. So you can basically click on every module and get some more information from there. The train model also returns the parameters, like the settings and the weights. And I think no, it doesn't. So it just gives you some information back about the algorithm. Oh, I see a hand all over there. Can you yell really loud? Yes. So basically the question is, what comes out of that tuned model hyperparameters is based on the training data. Is that also the best for the test data? Yeah, no, not necessarily. That's always the difficulty, especially this is a very small data set, so there is a bit more, the variation is more noticeable here. But in general, if your training data set, your test data set should be a representation of your training data set as well. So they would be closer together and not that far apart as here in this example. Good question. We've trained the model, so we're done, right? We can all go home. You can all go home and tonight say, okay, I trained a machine learning model. It was really easy. It was drag and drop, connect, and press play. But eventually you want to use this in production. So what I'm going to do is I'm going to deploy a web service. And what you can do in Azure Machine Learning is you can use your trained machine learning model, convert it into a web service, and use it in production. So I'm going to remove a couple of things that we don't need. I'm only going to use one algorithm. I need to run it again, and then I can create a web service. And this is something that I actually really like about Azure Machine Learning, because if you've built a machine learning model and you want to use it in production, so for instance, you're using a third-party application, user inserts data, data gets stored in SQL Server, and you want to predict based on the data that's coming in. If you want to do this now, it can get pretty complicated because you have to run an external script, you have to do a prediction, write it back again. How are you going to host that code? Are you going to do it in like a repository? How do you make sure that changes get deployed correctly? All those kind of things that you also have to deal with software development also applies to machine learning models. So you want to store them somewhere where they are saved, where they're being backed, where changes are being logged, where you can have multiple versioning, things like that. And Azure Machine Learning kind of takes care of that for you. Because you can go back to this experiment, make a change, save it as version 1.2, deploy web service, and you got the next version running in production. So I'm going to set up a web service. And now magic is going to happen. Look at that. It's animated. There was someone at Microsoft that was like, okay, we're going to create a web service. This is my chance. I'm going to stun everyone. Let's make an animation. And it moves automatically. It's really the best part of the product. What you have here is that it kind of combined a number of things that we've done. So instead of seeing all that train model, score model, evaluate model, we got kind of like an experiment created on blah, blah, blah. This is the name of our experiment. This is our model. This is our trained model. So this is our linear regression algorithm, our trained model. And what we can do is I'm going to delete this little line here. I can connect the web service input to my score model. So this means I'm going to input some data through a web service. It's a RESTful API. I'm going to send it to the model. The model is going to predict. And the little one at the bottom, the color schemes are pretty awful. The output, it will return a prediction. Very simple. I need to run it. You also see you get a new tab here. So you get a training experiment and a predictive experiment. So that's how Microsoft sees those two worlds. First you do model training, you create your machine learning model, you select an algorithm, you train it on data, and then you want to bring it to production. Then you got a predictive experiment. It's trained, so we can deploy it. And you get to this page. And what you can see here is a familiar API key. You can access this through, it's just a RESTful API. So you send in this key as an authentication method, you send your data with it, and you get data back. Let's test it. So this is, for instance, one way to test your predictive experiment, is you can fill it with test data. So I'm gonna click enable, and it will fill in some random values. And everything that is a categorical value has been turned into a Dropbox. So you can easily see all those categorical values there. And I can click test, and now it will do an API request, and we get a scored label back. You also notice I supply the price, because it now generated the data from my sample, so it just filled in the price as well. If you want to, you can also, and you should, because normally you don't have your prediction results already in your data set, because then you don't need to predict anything, you would remove this column. But because it's part of the training data set, it also gets returned here. So you would normally cut off that column. There's a module called select columns, and you would say, okay, select everything except or select everything except the one I tried to predict. So it doesn't get returned. So the beauty of this is that this also comes with a whole load of options on how can you use this. So how can you use this RESTful API, even with complete sample code in C#, Python, and R. So you can see exactly these are fixed values, but here you can put in your own values, how to do the API call. So this is very, very powerful. All of those web services are available to the web services button, and you can get the information from them here. By clicking on them, you can go back and you can test them again. I don't have Excel on my machine, but you can also connect Excel to Azure Machine Learning. There's an Azure Machine Learning add-on for Excel, which you basically say, okay, these selected cells, push them to Azure Machine Learning and give me back a prediction in this column, if you want to. So very powerful, and automatically takes care of all your versioning of your model. Your model is being hosted in your environment. You can use C#, Python, Java, whatever your programming languages is, and just do a REST API call and get the predicted value back. It's very, very useful to have for when you're doing data science in production environments. It's also very quick. So normally, if you do like single request, it responds in milliseconds. Kind of course, based on what you're sending back. So if you're going to do image classification, what you technically also could do using the API, if it gives back big images of stuff like that, it's going to take a bit longer. If you have a lot of data to score, you can also use the batch service. So you can basically use the batch API and send in like 1,000 rows to batch process inside Azure Machine Learning. All right. Demo. We did that. Any questions? And only if you can scream very loud. Yes? The web service is not part of the free version, but the web service is part of the paid version, and they are, I think you pay separately for them, for the web service. I don't know how much it is. It's based on the number of predictions that you do. Yeah. Yes? So the question is, can I modify the algorithms used by Azure Machine Learning? No. You can only configure the parameters, but if, for instance, you are using an R or a Python algorithm, like generalized linear regression in R, you can load that library into run R script. You can use your own algorithm if you want to. Okay, anyone else? Yeah? Can you download the model and run it locally? No, unfortunately. Yes? Yeah, so can you share the model? Yes, you can in Azure Machine Learning. My model object is stored as a separate module inside my workspace. So if multiple people have access to my workspace, they can share the model in between them. Outside of the workspace, I don't think it's possible. So only inside your Azure Studio workspace, so to say. Quick note, there's going to be a session right after this one about doing this in database that also shows how the REST API works. It's the other session that I'm doing, so I'm not promoting my own session here. But if you're interested in seeing how you can do it through SQL Server, you could visit that session. All right. I think we're right on time, so thanks all for coming.